If you're modeling data for highly scalable applications, you'll want to know about JSON. So let's take a look at it and why Couchbase stores it by the bucket. The short answer is it's a very flexible way to store data, and it has low impedance with your code. So what is JavaScript object notation? Well, as the name implies, it was originally created for JavaScript, but it's a lightweight data interchange format that is completely coding language independent. It's just text. It's nested key-value pairs and lists. There are two fundamental structures. The object. Objects are collections of key-value pairs wrapped in braces. And then there's the array. An array is an ordered list of values wrapped in brackets. In a JSON document, elements are comma-separated. Text is wrapped in quotes, could be single or double quotes. That does not matter for JSON as long as you are consistent, although it may matter to the target environment by which the JSON is consumed. It may treat them differently. And then if you have other values which might represent a number or a null or a boolean, those would be left unquoted by convention, although again the specifics around that are determined by the target environment. JSON itself is simply text in a file. So let's take a look at how you structure data in JSON. First, the array or ordered list may have like or diversely typed values within it. In this example, it's all strings. Notice each string is separated by a comma. There is no comma after the last string. It's wrapped in braces, and in this case, double quotes are being used, although it could be single quotes. Again, it would be the target coding environment that would determine whether or not that made any particular difference. An object, you might also think of as a collection, is a set of like or diversely data-typed name-value pairs. Here, the values are a string, a number, and a boolean. Now notice the key of each pair on the left-hand side of the colon is quoted. Again, could be single or double quote. The value on the right-hand side of the colon, here we have a string value Jan, a number value 53, and the word true, which we're assuming here would be interpreted by the target environment as a boolean. The whole set is wrapped in braces. And then you can combine these. So here we see an array of objects. Two objects. Note that the first has a comma after it. Also note that there is no comma after the second. And both of them are one after the next inside a set of braces. Now if you kind of mentally turn your head sideways and think about a set of objects with common name values, you'll see that it can represent tabular data. But you can go a lot further than that with JSON. Here we see that the objects within the array have been extended with a fourth attribute each, pets. The value of this attribute, though, happens to be another array. So you can mix and match these structures however necessary to represent the values you need in your application. So then why store data as JSON documents? Well, think of your application. Imagine you have a domain object which represents an order. It has customer, items, pay type. It would be easy to design a JSON document that directly maps to this data structure. So JSON documents have low impedance with your underlying code. It's very easy through many open source libraries to map back and forth between JSON and the underlying code. Further, Couchbase at core is a key value store. So if the value happens to be a JSON document, you can store them one after the next trivially easily in a system like Couchbase. So data representing your domain objects ends up being easily stored, retrieved, and mapped. The schema itself evolves over time because each document is potentially different. So as new attributes are discovered and become necessary to your underlying data model, you simply add them into the documents as you accrue them. The schema is inferred based on the actual usage patterns of your data structures. You don't have a fixed schema that you're locked into at the beginning of your project. Couchbase, of course, offers open source SDKs for virtually every major programming environment, making it very easy to work with JSON documents. So we keep mentioning this idea of a data bucket. So is a bucket like a table, or is it like a database? What is it? Well, a bucket in Couchbase is a logical container of uniquely keyed documents. It's a key space. So it's more like a database than a table. If that's so, then what is like a table? Well, where you happen to add documents of the same general structure, those function as might a table, except that you're not locked into a particular tabular format. Each document could potentially be different. So your schema is inferred from the data storage pattern that you actually use. You're not locked into a particular pattern up front, which means your data storage can grow and evolve along with your project. So why might you ever use more than one bucket? Well, there are various reasons, but they have much to do with broader Couchbase features than your data model. So you may have variant replication demands for different types of documents, or perhaps highly distinct access patterns. Those might urge you to use different buckets. That's discussed further in other courses, such as our CB30 course. Or you might have mixed document structures, and you could have one bucket holding JSON, one holding XML. At core, Couchbase is a key value store. The value can potentially be any binary format up to 20 meg per document, as you've seen already. We simply urge JSON because of its flexibility and because of the power of our nickel querying language. So what have we learned here? First, JSON is a ubiquitous, lightweight data interchange format that is focused around arrays and objects, where an array is a bracket-wrapped ordered list and an object is a brace-wrapped key-value pair, all separated by commas, strings, singular double quoted, other values unquoted, and you nest these one inside the next as necessary, which means that JSON is an excellent data storage medium because the physical structure of your documents can correspond very closely to your domain objects, reducing impedance and making your code simpler to write and maintain. Also, because the documents are not locked into a rigid schema, you can evolve their structure over time as your own software evolves. Last, because Couchbase evolved directly from in-memory caching systems, these documents are accessible extremely fast. Last, we learned that Couchbase buckets are key spaces. They're containers of uniquely keyed documents of potentially any structure. Each of these buckets roughly equates to a relational database, not a table, however. You have the functional equivalent of a table when you choose to work with documents of a generally similar format. Although, as you'll learn, our querying language nickel easily accounts for missing values and completely missing attributes. We've got a lot more to cover. Stick around.